I came in with Dan Dare.
Yes, you would fit into that.
Yeah. Eagle number 2. For some reason, I didn't get Eagle number 1. But I was there from Eagle number 2, and I read those, I guess, through to, I guess, The Man from Nowhere, which I started to lose track. I don't have a pile of these comics sitting in the thing, but it was the time that I was getting interested in astronomy and science fiction and so forth, and it had definite influence on what I did, and eventually I went on and became a rocket scientist like these guys, and went on from there. Going back, this is, and my memory gives me problems a little bit, because I remember the comic and I remember reading it on the way to school, but it's the wrong school. Because in 1950 I wasn't at grammar school, and I remember it in terms of the grammar school. So this is part of the problem I have. But I was already getting introduced to things. I was interested in astronomy. I had an uncle who had a pile of old, amazing, pre-war amazing science fiction magazines in the back of his garage, which I read my way through, got familiar with Doc Smith and the Lensman. Anybody know Doc Smith is? Hooray! We've got a few civilized people in. And one of the things that he gave me at the time, like mine did, was he gave me this book, which he got as a young man, which was a book on astronomy. This is 1950. This book had been published in 1920 when I got it, and it was still on astronomy. It's an interesting book, and it's the sort of background to the worlds that Dan Dare was going to visit. It's an interesting book on astronomy because it has one chapter on each of the planets, including one that isn't there, the planet Vulcan, which was supposed to orbit inside Mercury, and then 2 or 3 chapters on the rest of the universe. 10 years later, when I was at university, the book on astronomy had one chapter on the whole of the solar system, and the rest of the book was somewhere else, and it was sort of grudgingly on the solar system. This is the world that started off in the Dan Dare system, and I thought what I'd do now, rather than talk about Dan Dare particularly, because it set me with it, science fiction people talk about sense of wonder and so forth. This is where I got the idea that the rest of the universe was interesting, fascinating, gave me a sense of wonder. And so instead of talking about Dan Dare, what I'd like to do is to revisit the planets that Dan Dare visited now, and tell you some of the things that get me in the same way that Dan Dare got me then about the planets. I won't go through the normal routine about things, but tell you the things that make me go, gosh, despite the fact that the universe is a lot less hospitable to human beings than Dan Dare portrayed, it's still got that same sense that I got out of those early Dan Dare things. So we'll start with Venus. Here's Dan Dare landing on Venus. I don't have access to all your great, glorious picture libraries, so the number of Dan Dare pictures I can put into this is very, very limited. And down below here on the test stand is Venus Express, the European mission to Venus with a mapping mission and various other things that we at Stevenage has things to do with. And what we discovered, and in 1950 you got this wonderful cloud-covered thing where you can imagine anything underneath, and the science fiction people did. Astronomers were beginning to worry that perhaps this idea of a hot, lush, tropical, wet environment wasn't there. Here's Dan Dare landing on this rather tropical environment, and here are the pictures from the Venera landings, what it actually looked like. Rather barren, rather hot, rather unprepossessing at the time. Since then, Venus Express in particular looked at the atmosphere, and it's now, and these are artist's impression from the Venus Express data, volcanoes, and I'll talk in the next slide just a bit more about volcanism on Venus and ferocious lightning storms in an atmosphere where the clouds are sulfuric acid and the atmosphere is largely carbon dioxide, and the temperature, well, we'll deal with that again. Now we've radar mapped the surface of Venus. The colours here, the false colours here, represent altitude more than anything. One of the things about Venus, however, that starts to get this sense of wonder is that because it's got no seas, it doesn't have any plate tectonics. The surface of Venus is one plate that doesn't get resurfaced by the weather, as it were. One of the fascinating things about this is there aren't any craters on Venus. Now, it's not that there's a thick atmosphere which protects it. There would still be craters. The conclusion is actually that the surface on Venus isn't very old, and that from time to time, the whole of the Venusian surface gets resurfaced by volcano action. That everything gets redone from time to time. That's kind of one of these fascinating things that suddenly gets me. Hang on a minute. They have a volcano which completely covers the surface. Another one that's fascinating here, the temperatures that we've got here are hot enough to evaporate some metals. The high mountains have bits on them that have very high radar reflectivity. They're plated with metal, probably. Think about that, instead of snow. Yeah. Here's that's from the radar altimetry data, one of the big mountains that's almost certainly volcanic there. So Venus is still a fascinating place. Under the clouds, there's all sorts of things. Another of the interesting things, one of the things that the pre-1950s book said was it must rotate because if it had one face permanently faced to the sun and the other face permanently away from the sun, all the atmosphere would condense out on the cold side. In fact, atmospheric circulation, it rotates very slowly. In fact, it rotates it rotates anyway rather more slowly than its year. But atmospheric recirculation means that the temperature on the unlit side is very similar to the temperature on the sunlit side. I'd forgotten how Dan Dare got to Mercury until one of our speakers reminded me that it's after the Red Moon mystery they crash land on Mercury. My book says Mercury faces one side to the sun, the other side permanent darkness. There's a twilight zone around the edge where the temperatures might be reasonable. It is gravitationally locked to the sun, but it's 1 to 2. It rotates once every 2 Mercurian years. So unfortunately, you don't get this twilight zone at all. If you're going to get a twilight zone, it must be somewhere near the poles. Unfortunately, Mercury is so far down close to the sun, it's very difficult to get to. The first spacecraft was Mariner 10, which didn't actually go into orbit around Mercury. It sort of did a swing by and took pictures on the way past. Now NASA has a probe called Messenger, which is round Mercury doing mapping, and there's a European project, EpiColombo, which I was partly involved in, where we actually looked for a while until they decided they didn't have enough money at landing close to one of the poles, and I know exactly what the problems of getting into the twilight zone around the poles are there. It was a challenging problem, but they couldn't afford it in the end. But as I say, Mercury is an elliptical orbit, and it goes round the sun in an ellipse, and once every second time round, the same face is closest to the sun. It's tidally locked, but it's tidally locked in a rather more unusual fashion than you would expect. This is the messenger map of Mercury, and this again is false colour. The blue, the blue patterns of this are basically lava fields. It's pockmarked with craters, impact craters, but there's also been an awful lot of volcanism that's created the surface that we know about Mercury. There's all sorts of interesting things. The magnetic field's not central, and nobody quite knows why the magnetic field's not central. And the surface is black, which the latest thing says it's probably, over the years, acquired a layer of soot from passing comets that sort of darkened the surface unusual. The one that I like on Mercury is one that you don't get very often told about. This is from the Mariner 10 pictures originally, and then later from Messenger. One of the biggest single objects on Mercury is this large rim crater called the Caloris Basin. And I give this as an example to people who say science always takes the magic away from things, because it's a boring picture until I explain this picture to you. This is 1550 kilometers across this basin. And we kind of know what created it. We know that since it was on Mercury, the incoming body that created this was probably coming in at about 50 kilometers a second, give or take something. And it was probably about 50 kilometers in diameter. Think for a start, that means that it took a second for this thing to collide with Mercury. On the way in, we can calculate how much energy was involved in that and what sort of temperatures were involved. And roughly, again, finger in the air, about 1 million degrees this fireball was as it collided with Mercury. That, we work out how much it radiated back. And for about 5 seconds when this happened, Mercury was the brightest object in the solar system, including the Sun. The diameter of this is the horizon as seen from a 50-kilometer fireball. So it melted Mercury's surface from horizon to horizon. In fact, there's missing material. If you work out how much material there's missing material in this area which is gone. If you look on the opposite side of Mercury to Caloris, there's very funny terrain, which is where the earthquakes that were created went all the way around the planet and met one another coming in the opposite direction. It's a more interesting picture now that you know what's created it.
So they know when it happened?
No. Probably late in the heavy bombardment period, but it's quite because you can do crater counts and so forth, if you believe them. I'm not sure. I always get the thing. Now I had to kind of remember how the stories went, and of course Mars comes before Mercury in the sequence of stories, so I've got this slightly out. And of course 1950, this was the sort of picture people had of Mars, and this is the map produced by Giovanni Schiaparelli of all the canals on Mars. I say that to get told that scientists only discover what they're looking for. I'm not sure that's true. This is a very good example of where you don't find what you're looking for. When we got to Mars, none of that was there. That was all optical illusion. In fact, even the major features are difficult to correlate with current maps. What all these astronomers carefully peering through their telescopes at Mars had failed to see was the biggest bloody volcano in the solar system, 3 times the height of Everest, so wide, this is Olympus Mons, so wide that if we were sitting in the centre of it, it would expand over past Birmingham. And there's 3 more that are nearly the same size thing, and a valley that makes the Grand Canyon trivial by comparison. 1,500 kilometres long, splitting the planet almost. We've now got, and this is the companion spacecraft to Venus Express, Mars Express. Mars Express was the first one, which has done a lot of work there. We're still finding, and you read that in the newspaper, so I won't go too much on Mars, of things that it looks at the atmospheric composition. There's places where there's too much methane on Mars, that there ought to be from equilibrium, which suggests that something funny is going on there. Whether it's life, we don't know. There's a radar system on Venus Express which looks below the surface, a subsurface radar. We now realise that there's a lot more water on Mars than we thought there was, but it's buried under dust. In fact, the latest number that I got was that if you melted all the water on the surface of Mars, it would cover the surface of Mars to a depth of about 3 feet all over. And there's ice in the poles. When Dan Dare went skiing in the poles of Mars, yes, one of the poles is ice, the other is largely carbon dioxide. Going on, you already saw the eagle picture of the moons of Saturn. We seem to bypass Jupiter and went straight to Saturn. Now we've looked at most of the Saturn system through the Cassini-Huyghens space probe. This is the Huyghens probe as part of the Cassini mission. That was the European bit. The American Cassini was an orbital spacecraft which is still going. It's still working. Arrived there in 2004. It's still working. We're still in the final phase of it. Huyghens was designed to land on the one moon in the Saturn system, unlike Dan Dare, who had all his moons populated, the one moon that's got an atmosphere, which meant that we could do a re-entry vehicle and land on it. You see, I'll show you the picture everybody sees, but this picture was one of the first pictures. This is a picture taken on the way down of the surface when it's on the parachute, sinking towards the surface. I looked at this when it first came up and I said, it's the Yorkshire Dales. I can see the stone wall things. There's a road along here. No, unfortunately it's too cold and so forth. But there are lakes, they're liquid methane lakes. There's rainfall, there's things going on there. There are probably rivers and so forth. This is the surface picture taken from the Huygens lander, close-up of the surface with rather waxy rocks that have been probably rounded off by liquid passing them by. It's an interesting thing. More interesting currently is Enceladus. The astronomers have decided this is called Enceladus. No, guys, it isn't. It's a Greek word, and they're into cards. They're into soft C in the Greek word. It's Enceladus. It's a kappa, that second consonant. But I'm outvoted on this, I'm afraid. Enceladus is fascinating because it's got a liquid ocean. When I say a liquid water ocean underneath the ice. It's far too cold for water to exist on the surface. It doesn't have a real atmosphere. There's bits of things in it. The interior is kept warm by tidal forces from the other moons that it passes by, which keeps it warm. There's a crust of ice which is some kilometres thick, and there are areas down near the South Pole where the ice has cracked. And this is what's created all the furore. These stripes here represent cracks in the ice, and because there are cracks in the ice, the water can come out. And they discovered, and what you're seeing on the picture there on the right, is water and things being ejected from the surface, blowing off from the surface in a plume. And Cassini does complicated manoeuvres through all the moons of Saturn, and they can retarget it. It's coming to the end of its mission. One of its final parts of its mission is going to be to fly much closer through that plume and actually get analysis of what's in that plume. But one of the things we know is it's water and other things, salts and so forth. And while it's a moderately small moon, it's quite interesting because if there's water oceans and warmth underneath it, other things can happen. And that's one of the reasons I went on to Saturn before I went on to Jupiter, which is a bit close to it. This is Voyager pictures of Jupiter and its moons, which we've known about. Once again, you don't discover what you expect to discover when you do these missions. That's what's important. Don't remember Dan Dare going to Jupiter. Perhaps in later, one of you guys. The trouble of talking in this environment is I can't make a statement about Dan Dare without somebody knowing better than I do. Again, populating it with living organisms was probably not the right thing, but every one of the moons was different. Io, the nearest moon to Jupiter, surprised everybody. Nobody quite knew, when they got the picture on the left here, nobody quite knew what to do with it. It wasn't a scientist who discovered what was going on. It was one of the engineers running the mission profile on Voyager, looking at trying to get star fixes in order to navigate it, saw this thing, and it took her a little while to work out what she was looking at. And it's a volcanic eruption. It was the first time people had actually seen an erupting volcano outside the Earth. It's because of the low gravity, it rises to about 120 kilometers above the surface. Almost nothing on the surface of Io is permanent. While things have got names, come back in a couple of centuries, they will have to rename, go through the naming process all over again. Fascinating thing, but perhaps of academic interest. Europa is more interesting because it's kind of like Enceladus, except it's bigger and there's more gravitational force warming up the inside. We know that there's a liquid interior to Europa. We don't know more about it because there aren't any plumes coming up through the ice or whatever. But if you're looking for places that harbour life in the solar system, Europa is one of the possibilities there. It's covered in cracks all over the place, but you've got to find a way of digging through probably about 20 kilometres of ice if you're ever going to get down below that. How am I doing for time? Okay. So there's a lot going on here as well that we couldn't have guessed beforehand. My little book has names for the 4 moons and doesn't even recognise that Jupiter has got a ring system round it. Saturn, somebody mentioned one of the moons that they thought was there in my book isn't there. There's a lot more that are there that they didn't know about at the time. Going out, Uranus and Neptune, all the problems that people have with pronouncing Uranus, hard luck. It's a Greek word again, and it's OU, it's Uranus. You're going to be classical. These look less interesting, but they're different worlds to Jupiter and Saturn. Uranus has an axis of rotation which is nearly tipped over on its side. They have ring system, or certainly Uranus has a ring system. They have weather. We don't quite know what's driving the weather. We do know what's driving the weather on Jupiter. These quick looks as Voyager went by don't tell us, but there's a big vortex tornado, hurricane going on in Jupiter. There's something similar happening on Neptune, and we don't know how long it lasts, or what's driving it. But when you're getting right to the edge of the solar system where you think that everything's frozen out, and the thing that I found fascinating on Neptune wasn't on Neptune, but it was on the big moon of Neptune, Triton. And these little black smudges are volcanoes. They're nitrogen volcanoes. That's what we know about, and it's the plume has deposited things. It's not what you would expect. This is where everything started to get boring there's nothing there but frozen waste, rubbish. It's still magic things going on at temperatures which are well down towards absolute zero, right out on the edge of the solar system. We just happen to be in a nice warm area, and we have difficulty in imagining what these things are like. Voyager, which is a spacecraft that took these pictures, because it's the one spacecraft that's been out there, is still on its way out, still working. And I should introduce you at this stage to my friend Ed Stone, who's been the project scientist on this. If you want to know what old scientists do, then wait. He's been project scientist on Voyager since it was launched in the 1970s. He worked his way up through the thing. He still is looking at Voyager, which is still sending data out from the bare fringes of the solar system. The two Voyager spacecraft are in different places. They are now getting to the point at which the influence of the sun is comparable to the influence of the rest of the universe, the so-called termination of the heliosheath and the heliopause. And we're now convinced that one of them at least is in that region and is making the right things, where the solar system progressing through the galaxy creates its own shockwave. We did a little bit on things, and so the end of this talk is really about what's happening now. The thing that's happening that is very instant is Dawn, Ceres, and Vesta, the asteroids. Everybody tended to think the red moon was nice spherical asteroid. Vesta at 530 kilometers is still not quite spherical. Ceres, which is now a minor planet, is pretty spherical. Dawn was designed to fly and stop at Vesta on the way, and then go on and stop at Ceres. It was at Vesta in 2011, is now at Ceres. Ceres looks interesting. It appears not only to be a ball of rock that's been hit by meteors and so forth, but it appears to have its own internal structure. It may even have had something approaching volcanism in it at that small size. It has some very interesting bright white spots here, which nobody quite knows what the white spots are, that suggests there's a lot of ice in the mix. It is even at that size, it's behaving a bit like a planet. Keep watching the news. There is a spacecraft launched in 2006 while Pluto was still a planet, called New Horizons, which is due to arrive there on the 14th of July this year. Currently about 500, what's that for? That's 5,000 million kilometres out and getting closer all the time. It won't stop there, it will fly by. This is the best image of Hubble that we have, Pluto that we have. Pluto is in an elliptical orbit, it gets close to the sun and it's on its way in towards the sun at the moment. And even the Hubble images say that the surface is changing. The surface is way, way down to the point at which everything is frozen out on the surface. Well, not quite. There are still things happening to that surface, and we're hoping that New Horizons will take pictures of the planet close enough to see what's actually happening to that planet in the next few months. And can't stop. Oops, that didn't work. And finally, of course, Rosetta, which has been firmly in the news. These are the latest pictures out of Rosetta that I could get off the ESA site. Rosetta's interesting. First of all, it's a cometary nucleus. It's a lumpy thing, a bit like an asteroid, but it's it's got a lot of ice in it. As it gets close to the sun, that ice starts to evaporate. It's already evaporating. We've got a spacecraft in orbit around it that is being influenced by running into that gas. Normally you can leave something in orbit, it doesn't slow down. This is keeping going through the gas plume. We've already had some control problems with Rosetta as the thing does, and ESA is having to take care about how it operates a spacecraft, and it will get more interesting as the comet goes in towards the Sun. And it's possible, everybody's keeping their fingers crossed, that the microscopic lander, the Philae that was ejected from Rosetta as it arrived at the comet, will eventually see enough sunlight again to start the thing up and give us some more data, though it gave an awful lot of data in the few minutes it had before its battery ran down. So the end of this story is just keep watching this space, because there's a lot still to come. But I hope that gives you some idea. The solar system's changed an awful lot since Dan Dare was things. I don't think it's become less interesting. There are a few Mekons in it, there are fewer Trines, but there are lots of interesting things to keep us occupied. Thanks.
Let's see if there are any questions. Any questions? I think you're all dazzled. It was easy. There's one. John's going to ask something very important.
You said that there's no evidence of impact on the surface of Venus.
There are some craters, but very few. If you look at the surface of the Earth, you have the same sort of thing. We know Venus and the Earth. Well, we know the Earth, for a start, has the same number of impacts as the Moon. Look at the Moon, you see craters everywhere. Look at the surface of the Earth, you have difficulty in finding them. We know they're there, but the fact that one hit the dinosaurs is 65 million years ago, the impact rate should be a lot more. On the Earth, it's because we weather, they disappear, the continents change, and everything happens. On Venus, there's a similar lack of craters on the surface, which tells us that the surface is not unchanging. Let's put it that way. We know why the surface of the Earth changes. We're still guessing a little bit at how the surface of Venus changes. But it looks awfully as though, because there's no continental plate tectonics going on, the volcanism on Venus is kind of inhibited. It gets warm underneath, and the surface crust is holding it all down. And that from time to time, the warmth eventually melts all of the surface and they start all over again.
The reason I asked the question is that when you showed us the radar map image, I could see one very large and one slightly smaller circular structure.
Good.
I mean, it was sticking out a mile.
Yes.
There are Earth craters on Venus.
Yes. Now, go back a bit. Go back even to that one. Look at that one, and you can see craters all over the place. And that's one that's fairly lightly cratered. If I go back to Mercury, it's saturated. Why is Venus not the same? And the answer is yes. We do have collisions from time to time. Surprisingly, actually on the Earth, we have rather more frequent asteroidal collisions than you're told about. We tend to think there was one in 65 million years ago. That's the last one. No, it isn't at all.
99.
I'm trying to remember the one in Sudan. When was that? Thought it was this century, but I could be wrong.
One in Russia, was it?
Oh, I mean, the one recently which didn't leave a crater, but there are cratering episodes on the surface of the Earth at fairly regular intervals, decadal intervals. Most of them land in places we're not terribly worried about. We'll start to get worried about the asteroid threat when one hits a city.
That's his only warning system. Jerry's going to go next.
Well,
Oh, sorry.
It's not Jerry. There's another Jerry in the room. Sit down.
On the subject of Earth impacts, the Earth receives on average about 139 tons of material from space every day.
Yes, but that's normally dust rather than
yeah. But you said that when New Horizons was launched, Pluto was a planet, which is true. As to what it is now, if you come along on the 25th of June, you will find out. My presentation is entitled "Is Pluto a Planet?" and I shall look at the IAU definition and I shall give a definitive answer that leaves no possible room for any further argument.
I'm afraid this is kind of the grumpy old man phenomenon in my case. Why did they have to keep changing the names of things? I've just got used to it.
Yeah.
Yeah.
Anyway,
there's an interesting point about Venus, the Earth and Mars. Venus may have had water at one time, but it lost it very rapidly through evaporation and dissociation in the upper atmosphere through dynamics that need to go into detail on here. The Earth has a very considerable ocean and has kept it, and has very active plate tectonics and everything that goes with that. There's evidence that Mars has had plate tectonics at some time in the past, and there's a good deal of evidence that it had an ocean, possibly largely in the northern hemisphere. This suggests to me that there's a possible direct link between the planets of the size range of Venus, Earth and Mars will have plate tectonics if they have a significant ocean.
Yes.
There must be a relationship between the two things. At least I think that the evidence would seem to suggest that that's the case. And that's one of the interesting things about doing comparative planetology, because it tells you quite a lot about your own planet. So
And the problem is that the story doesn't get more clear as we learn more. Currently, the story is less clear. We don't actually know where the water on the Earth came from.
yes, that's true. Besides, some people say comet bombardment.
I mean, I won't even bother to go into the debate on this one. It's worse than
What's the latest on the magnetic field of Venus?
It's got a weak
Isn't
field.
that
And that may be
plate
other things.
tectonics
Yeah.
more than
Well, it may be how things get out, but it may be all sorts of other things in there. There's still a considerable amount of hydrogen on Venus. It's just not water.
Right, any more questions? Oh, we're back at the back. Sorry.
Got to get your exercise somehow.
I've been told they keep finding moons around Pluto.
Yeah.
What's the current state of play with how many are there? And has that affected the flight plan of the probe on its way there?
A little bit.
Oh.
This is one of the. I used to do this many decades ago now for schools, and this sort of talk. 10-year-olds are the worst because they'll say, "How many moons has Saturn got?" And the answer is, "I don't know. I'm not kept up." How many moons has Pluto got? The answer is the same.
I heard that we found more while it's en route.
Yes,
that's the point.
As you get closer and as you look hard.
Yeah.
I mean, the Hubble picture of Pluto, really, we couldn't get time on the Hubble telescope until you got something going there, and then they say, "Oh, well, we better have a look at it and see what we can see." So you get that sort of problem going on. That because. I have to be careful. My son's an astronomer. I'm about to express heresy. The astronomers are generally not interested in the rest of the solar system. They've got a big telescope. They're interested in the origins of the universe. And so, far from my original book, which has got lots on planets and very little on the rest of the universe, it's completely upside down now. And planets are the interest of geologists and planetary they call themselves now, but basically earth science people, not astronomers. The astronomers get the money to get big telescopes. And so there's a permanent antagonism. They also get money to put big telescopes in space. And when you're fighting for a planetary mission and you find that the astronomers have got it all sewn up, because if you give them another couple of billion euros, they can give you the secrets of life, the universe and everything. Sorry, this is...
Right,
You'll gather there's some personal...
There's some champagne.
Yes.
Well, I don't want to keep you from the champagne. Just to follow up on that,
I was
though.
going to sum up, but I was going to
Sorry,
say...
All right,
Jerry, he wants to ask.
Yeah,
Just
you can't sum up the unsummable, and it will only be eating into the drinking time. So
no, it's all right.
we'll just go.
Well, just as a it's an answer. The official total for Pluto is that it has 5 moons. When the 4th one was discovered, I wrote to Mark Showalter, who led the discovery team, suggesting the name Cerberus for it. And I also suggested that if they should ever discover a 5th moon, that the name Styx would be appropriate. A year later, they discovered a 5th moon. And a year after that, they announced that the 2 names would be Kerberos with a K rather than a C, and Styx. So,
we owe it to you.
so there we go. So now we can go and have champagne.
Well,
Copyrighted though.
Jerry's going to say a farewell.
No, I just said it.
Right, he said it.
Actually, all right. I just ought to thank everybody who was absolutely marvellous, because all the speakers turned up. They all spoke on time. What more can you ask?
Yeah, fantastic. Thank you all for coming along.
And they all talked marvellously.
A fantastic day. I wish Eagle was still here. I'd still be reading it. Thank you.